This is the video for accelerated geometry on section 15-3 on logarithmic functions. The essential questions you should be able to answer by the end of this video is how do you convert between exponential and logarithmic functions, and how do you analyze the graphs of logs. Logarithms are simply used to find unknown exponents in exponential form. So the whole point of learning logarithms is to be able to find and solve for exponents. Exponential form takes on this. You have a base raised to a number, your exponent, equals some other number. Log form, you have the log of the base of a number equals, and this y is the exponent. So for example, 10 to the third equals 1,000. In log form would become log base 10 of 1,000 equals 3. 1,000 was what it was equal to, which is your x. So over here in the x spot, we put in 1,000. Your base was 10, so in the base spot, we put 10. And our exponent was 3, so the equation became equal to 3. Another one, we could say 2 to the fifth is equal to 32. So I could rewrite that as log. The base is 2. The number that it was equal to was 32, and the exponent is 5. Also, I want to make note here that log base 10 of 1,000 equals 3. You typically will not see log base 10 written like this. It will typically just be written as log. And if you just see the word log, it is implied that the base is 10. Let's try some more. We have 1/4 to the negative third equals 64, and I want to put it in logarithmic form. So I'm going to have the log, the base is 1/4, the number that it was equal to was 64, and the exponent is negative 3. Now I'm giving you the log form, and I want you to put it in exponential form. So we have our base is 3. What it's equal to is actually your exponent, so that's going to be 3 to the fourth. And then you have 81. Let's try another one. Your base is 16. What the equation is equal to is your exponent, so that's 16 to the 1/2 equals 4. As I mentioned earlier, if it's log base 10, you're just going to see it written as the log, and that's because it is what we call our common log. It has a base 10. So if I'm solving for x here, it's in exponential form, so I'm going to convert it to log form. So that tells me that the log base 10, but remember, we don't have to write that, of 85 equals the exponent. On your calculator, you should have about 3 buttons up from the on switch. It says log. So now you can just hit the log and type in 85 and hit enter. And you should get that x is about 1.929. Number 4, we have 10 to the x equals 1 over 109. So put it back in log form. So that's going to be the log of 1 over 109 equals x. So now type this in your calculator. You should get negative 2.037 equals x. Let's try some more that are a little bit more difficult. Number 5 says 4 equals log base 3 of a, and we want to solve for a. So if it's in log form, you're going to convert it to exponential form. So that might be something you might want to make note of. If it's in exponential form, you're going to convert to log form to solve. If it's in log form, you're going to convert to exponential to solve. So to convert this to exponential, your base is 3. The exponent would be 4, and that has to equal a. So in my calculator, 3 to the 4th is 81. Number 6, your base is 4. The exponent is a, and that has to equal 64. So now I have to ask myself, 4 to what power is 64? So if you need to start doing in your calculator, 4 to the 1st, 4 to the 2nd, 4 to the 3rd, 4 to the 4th, and so forth until you get 64, you will see that 4 to the 3rd is 64. So a is just 3. Number 7, your base is 125. Your exponent would be a equals 5. Anytime you have a bigger number raised to an exponent and the result is a smaller number, you should know that your exponent is going to be a fraction. So we have to figure out that 125 to what power is equal to 5. And that tells me that 125 to the 1/3 is 5. So a equals 1/3. And you can also kind of think of it as 5 to the 3rd is 125. So then 125 to the 1/3 has to equal 5. Let's try another one. We have the base is going to be a. The exponent is going to be 5th equals 32. So what number to the 5th power equals 32? And the answer to that is that 2 to the 5th is 32. So a is just 2. Number 9, you would have 3 to the 1st equals a, and 3 to the 1st is just 3. Number 10, put it in exponential form, you would have 10 to the a equals 1. The only number that we can raise anything to and get out 1 is 0. So that tells me that a has to equal 0. Number 11, you would have 7 to the a equals 343. So again, I'm going to start checking in my calculator, 7 squared, 7 cubed, 7 to the 4th, so forth. And you will get that 7 cubed is equal to 343. So that tells me that a equals 3. Number 12, your base is 8. Your exponent is 1/3. And type this in your calculator, and you will see that a is 2. Number 13, we have a to the 5th equals 243. And we can start thinking, what are our perfect fifths? And it comes out that 3 to the 5th is 243. So a equals 3. Now in class, I will also show you another way that you can figure this out without actually have to guess in your calculator. But you do have a way that you can actually take the 5th root of both sides to get your answer here. But I'll show you that in class tomorrow. So make sure you have your graphing calculator. Next, let's look at the graphs. The graph of an exponential function you spent a lot of time last year looking at with your exponential growths and decays. And then our new one is the log, which is y equals the log base 10 of x, which again, in your calculator, you would just type log of x because it has a base of 10, would come out to equal this. And if you notice, they are reflected across the line y equals x. So these two are inverses of one another. If we talk about the domain of the exponential, we can type in anything, so that's going to be all real numbers. Our range, however, you will notice that it approaches 0 here, but it will never cross that x-axis, so that tells me y is greater than 0. We also have what we call an asymptote. And because this never crosses the x-axis, that's where your the imaginary line here that it can't ever cross is what we call our asymptote. So in this case, it's going to be y equals 0. Looking at the log function, your domain, if you notice now, xy's, it doesn't have any of the negative numbers. It stops right here. So now your domain has to be that x is greater than 0. Your range, this keeps going and going and going, and this keeps going up very slowly, but it does keep going up. So your range is all real numbers. And now your asymptote is now the y-axis, which takes on the equation of x equals 0. Okay. In this set of examples, it says use the graph to state the domain and range, list the transformations, find any intercepts, zeros, intervals of increase and decrease, asymptote, and behavior. It also wants us to find the average rate of change between 5 and 7. So first step, we have y equals the log of x, which is the same function we just looked at. So looking at this, we see that the domain for x values never comes over to the negative side. So that tells me that x has to be greater than 0. Your range, this keeps going down, even though you can't see it, and this keeps going up. So that's going to be all real numbers. Because it's just the log of x, this is just your parent function. So there are no transformations. Your intercepts, well, since it doesn't cross the y-axis here, there are no y-intercepts. However, you do have an x-intercept, crosses right here at x equals 1. So we have the point there at 1, 0. Your zeros are where does it cross the x-axis, which in this case is at x equals 1. Intervals of increase and decrease. Well, if you read this graph left to right, it's always increasing. But remember, you have that restriction here of being greater than 0, so it's going to be from 0 to infinity, because your x values can't go below 0. For decrease, it's never decreasing, so we're just going to write that in there. Your asymptote, the imaginary line that it never crosses, which in this case is x equals 0. In behavior, on the right side, it's slowly going up, so that's towards positive infinity. On the left side, it's slowly going down, so that's going to be negative infinity. Average rate of change, it said between 5 and 7. So what we're going to do here is I want you to pause the video. I want you to go to your y equals and type in the log, and then you have a set of parentheses. So you're going to type in x and close the parentheses. And then I want you to go to your table of values. When you go to your tables and scroll down to when x is 5, you should have the number of 0.69897. And then if you look at 7, you should have the number 0.8451. So our average rate of change is just the slope between these 2 points. So we have 0.8451 minus 0.69897 all over 7 minus 5, which that gives me 0.14613 divided by 2. which comes out to be 0.073 and you can round this. I'm just using the exact numbers right now. Let's try one more. So we have y equals the log of x minus 4 minus 3. Again, you can type this in your calculator and y equals just like you see it. Make sure you put those parentheses where they are, and you will get a graph that looks similar to this. Okay, so if we look at this, for our x values, we have nothing over here, which means right here is our restricted x, which is at 4. So x has to be greater than 4. If you notice, it is also the same number that is right here. And you'll see why in just a second when we talk about transformations. Our range, it still keeps going down and it still keeps going up. So that means it's going to be all real numbers. Transformations, we're subtracting from x, which really, if you look at the parent function to this one, it's shifted to the right 4. And subtracting 3 here, we moved it down 3. Our intercepts, it's never going to cross the y-axis because we can't go below 4. So there's no y-intercept. For your x-intercept, if you go and look at your table of values with this problem on your calculator and you scroll a little bit, you will notice that you are getting nowhere close to your x-intercept. So for a problem like this, it is okay for you to write, there is one, because we know eventually this is going to go up, up, and cross the x-axis somewhere. However, we don't see it. Don't just write none, because there is actually an x-intercept, and we need to know that you realize that this does keep going up. It doesn't just stop. For zeros, it would be the same thing. You don't actually see where it crosses the x-axis here, but we need to know that you realize it does eventually cross it, so you can put the same answer right here. So there is one. We don't see it. Intervals of increase and decrease. So reading it left to right, it's always increasing. So remember, we can't go below 4, so it's going to start at 4 and go to positive infinity. Decreases, never. The asymptote, well, if x has to be greater than 4, so your asymptote is at x equals 4. In behavior, on the right, it's going up. On the left, it's going down. So again, for the average rate of change, we're going to go to our table of values, and we see that at 5, we have -3, and at 7, we have -2.523. So if we calculate the slope from there, we have -2.523 minus -3 over 7 minus 5. This gives me 0.477 divided by 2, which gives me 0.2385. Two more of these. We have log of x minus 2 plus 4. Again, you can type it in your calculator exactly like you see it, and your graph should look something like this. Our domain, the x values do not go below 2, so this is going to be x is greater than 2. Your range is going to be all real numbers. Transformations, it looked like it got shifted to the right 2 and up 4. Intercepts, it's not going to cross the y-axis, so so there's no y-intercept. The x-intercepts, since it starts here and we can't go below -2 here, and this is going up, there's not going to be any x-intercepts, which means there's not going to be any zeros. Our increasing, remember we start at 2 and we go towards infinity. Decreasing, it's always going up, so it's never decreasing. Your asymptote would be at x equals 2. On the right side, it's going up. On the left side, it's going down. Go to your table of values and scroll to 5, and you should get 4.771 and 4.699. And when you calculate this, you should get -0.036. One more. Our domain looks like it's everything to the right of 4, so that's going to be x is greater than 4. Your range, it's going to continue going up here very slowly and going down very slowly, so it's going to be all real numbers. Transformations, well, now you notice that there's a negative out front, and you will also notice that instead of going up, it's now going down, so that's going to be a reflection across the x-axis. The -4 really shifted to the right 4, and the +1 moved it up 1. For our intercepts, if we type this in our calculator exactly like you see it, because you can see that you're really close to finding your x-intercept here. So if you go to your table of values and just scroll a little bit, you will actually see that the x-intercept is at 14. But again, it never crosses the y-axis, so the y-intercept, there are none. Our 0 would be x equals 14. Increase, now if you look at your graph, it's constantly going down, so increase would be never, and decrease would be from 4 to infinity. Your asymptote would be at x equals 4. On the right now, it's going up. On the left, it's going down. I'm sorry. On the right, it's going down. And on the left, it's going up. Average rate of change, you should have, if you look at your table of values, plugging in 5 gives you 1. Plugging in 7 gives you 0.52288. Calculate the slope between these. And you should get -0.2386.